Have you ever wondered, why does the LED on your ESP32 always go back to its default state every time you reset or lose power? Well, that's because the ESP32 only stores data temporarily in RAM, so once power is lost, everything is gone. In this video, I'll show you how to make your ESP32 remember the last LED state by saving it to SPIFFS, a lightweight file system stored on the flash memory. And to make it more visual, I'm also using a TFT screen with LVGL to display the LED status in real time, so you can easily see the result right on the screen. Let's get started. For the hardware in this video, I'm using an ESP32 room module with 38 pins and a 2.4-inch TFT display powered by the ST7789 driver. And of course, we can't forget a simple LED so we can clearly see the LED status in the most straightforward and visual way. I've already assembled all the components onto a custom PCB, which makes everything look much cleaner. This board also includes a rotary encoder to help navigate the UI built with LVGL. I've shared the full wiring diagram and Gerber files in a previous video. You can find it right here on this channel. So in this video, I'll focus mainly on the source code part. In this part, I'll show you how to create a .txt file to store the LED state and upload it into the ESP32's SPIFFS. Inside the project directory, I created a folder called Data. Then inside that folder, I made a .txt file. You can name it whatever you want. In my case, I named it state.txt. Once that's done, go to the Platform I/O extension, look under Project Tasks, select Platform, and click on Build File System Image. After the build completes successfully, click Upload File System Image. And that's it. The state.txt file is now uploaded into the ESP32's flash. In the next part of the video, we'll use this file to store the LED state in the ESP32's flash memory. Now back to the source code. I created a simple toggle button using LVGL. You can easily find similar example code on the official LVGL website. As I mentioned at the beginning of the video, I'm using a rotary encoder to control the UI with LVGL. Here is the function where I initialize the encoder for LVGL. We need to declare an encoder input device, indev, and create a group to hold the objects we want to interact with. The encoder indev and group are initialized in the group init function. I've already covered this in several previous videos, so I'll just skim through it here. Inside the GUI init function, we set the focus on the group and assign the encoder indev to the group to enable interaction. In this example, when the encoder button is pressed, the focus will move to the LVGL button. Then we check if the button was pressed, change the label, and toggle the LED state between on and off. Next, I'm going to build and upload the source code to the ESP32 to test if the UI is working properly before moving on to the part where we handle saving the LED state into SPIFFS. Once the upload is complete, I test the UI, and as you can see, everything works fine. Now, in the final part of the video, we'll handle the code that saves the LED state into the ESP32's flash using SPIFFS. In the source code, I will create a state variable for the button. Next, I'll separate the LED control logic into its own dedicated function, which will operate based on the state variable we just created. Then, I'll replace the condition inside this if statement with the newly created state variable. Alright, now I'm going to start with the code related to SPIFFS. First, I'll create a function to initialize SPIFFS using the SPIFFS.begin command. An important note, make sure to include the libraries SPIFFS.h and fs.h at the very top, before any other libraries, otherwise you'll run into an undefined library error. Next, we need to open the previously uploaded file system using the SPIFFS.open command. The value inside is simply the name of the file we uploaded earlier. In my case, I named it state.txt, so we just need to enter that exact name here. I also add the letter R, which means the file will be opened in read mode. I create an if statement. If the file is successfully opened, it will read the string stored in the file system. I create a string variable named SaveState and use the file.readString function to read the stored string. Then, I remove any whitespace using the trim function and assign the button state variable based on that string. If SaveState is 1, set the state to true, otherwise will false. After that, I close the file to free up RAM. Finally, I add a debug monitor to track the current state. After that, move the update button state function into the if block to update the LED state. As mentioned earlier, if the string in the file system is not 1, the state will be set to false. Next, we will handle the function to write data into flash when the button is pressed. Next, I call the spiffs.open command to write data into the previously created state.txt file. I add the character W, which means opening the file in write mode. Inside the if block, when the file is opened, if the button state variable changes, it will write a value of 0 or 1. After writing the data, I close the file using the file.close command. Finally, I add a debug monitor command to track the process. The next step is to move the SPIFFS initialization and file reading function into void setup so that the file system is read every time the ESP32 starts up. Next, place the update button state function inside the GUI action function to update the LED and button state each time the encoder is pressed. At the same time, copy the SPIFFS data writing function into the same GUI action function. Now I will build and upload the firmware to the ESP32 to see if it works. As you can see, the screen doesn't display anything and the ESP32 keeps rebooting. You can see the continuous rebooting on the serial monitor. After some time, I found the cause. The SPIFFS function was initialized before LVGL. The simplest fix is to move the SPIFFS initialization after the LVGL initialization. I proceeded to build and upload the code again to the ESP32. As you can see, the screen now displays normally, but when I press the rotary encoder button, the button state does not change. The issue here was that I didn't add a function to toggle the button state variable. I went back to the GUI action function and added the toggle functionality so that each time the encoder button is pressed, the state changes. Then I built and uploaded the firmware again. The final result. When I press the encoder, the button changes its state and the value is saved to SPIFFS. You can see this in the debug output on the serial monitor. This is the testing part of the whole process. As you can see, I can turn the LED on and off, change the button state with LVGL, and save it to the ESP32's flash, all in a very visual way. I hope this video has been helpful for you. If you found it useful, don't forget to leave a like, share, and subscribe to the channel. See you again in the next videos.